Hello, folks. Welcome to today's series. And today we'll be discussing relations, mappings, and functions. And our main focus will be on relations and mappings. And in the next series, we will consider functions. Now, what do we need to know? We need to know what the domain, codomain, and range is. So now, if I have two sets, and I want to find the image of one element in the first set to give me another element in the second set. Now, the place I'm picking my first element is what we call the domain. And the place the images are going is what we call the set the images are going is what we call the codomain. So we have domain and codomain. And now I say that the image of A is 3. And I'll say that the pre-image of 3 is A. So that's how we work between domain and codomain. But what's the range? Now the range is to what extent, what are the elements in the codomain that are covered by the images? That's what we call the range. Now let's start begin with the definition of relation. Now a relation is just an association between two sets, say A and B. Now it's like saying that for a particular element in A, I will pick another element in B. So it's like we have an ordered pair. So for an element in A, I can find an element in B and pair them in that order. For example, in this illustration, we have a set A containing people and a set B containing fruits. So we could see that Amma may prefer mango, apple, or orange. Kofi may prefer all of them. Kojo might prefer none of them. So this is a relation. So you can say that Amma likes mango. So you can say Amma, mango. Amma likes apple. Amma, apple. So you can see that we can have so many pairs. And remember, the fact that Amma likes mango doesn't mean that Kofi doesn't like mango. So, like and the image need not to be unique. For relations, the image not to be unique. And Amma can like mango and Amma can like apple at the same time. So now, based on this, let's look at the types of relations. Now, the first one we will discuss is many to many. For many to many, we have several elements in the domain being mapped to several elements in the codomain. And also, elements in the codomain will have several preimages. So, for example, we can see that A is mapped to 1, 3, and 4. B is mapped to 1 and 4. Now you can see that 1 has preimages A and B. 4 has preimages B and C. So this is many to many. There are a lot of actions here and there are a lot of actions back. Now, we look for 1 to many. 1 to many, we have one element mapping to a lot of elements in the codomain. So that's what we call 1 to many. And for many to 1, a lot of elements map to one element in the codomain. Now, 1 to 1 is when we have one element mapped to exactly one element in the codomain. Every element in the domain maps to exactly one element in the codomain. So that's what we call 1 to 1. Now we know what the relations are. Now let's define map. What's a map? So a map is a relation where every element in the domain has only one image in the codomain. So from the above definition, we could tell without ambiguity that many to many and 1 to many relations are not maps. Sometimes in maps, you'll be given a nice map and you will ask to find the rule of the mapping. How do we do that? That will be our next focus. Let's look at the types, the rules for mapping. Now, the first one we consider is linear map. A map is said to be linear if a difference between two consecutive elements in the domain are equal, and the difference between two consecutive elements in the codomain are also equal. So we can always represent a linear map by this relation y equals ax plus b, where X represents an arbitrary element in the domain, Y represents the image of that particular S we've chosen, and A is the ratio, is the common difference in the two consecutive elements in the codomain to that of the two consecutive elements in the domain. Now, after we've established, evaluate, found our X, Y, and A, we can now determine our B from the above. Now let's consider some problems. So I have some four problems, but I'll just try one and I'll leave the others for you to try. And if you have problem, you always know you can reach me via email or you can leave a comment below. Now, the first problem is we should find the rule of the mapping. For us to first try the question, we need to verify if it's a linear map. So we find a difference between consecutive terms and whereas that they are the same. So now we know it's a linear map. Now first our first question is to find A. Now, like we say, A is the ratio. Is the ratio. So my A becomes this. And I can also equally find A by using this other element. So take note, once I choose my Y to be 3, I have to, and I choose my Y to be 3 and 1, I choose my corresponding X with respect to that. So we cannot choose different elements, you cannot choose different elements. We have to take note that it has to fall in the same thing. Now, I now I know what my A is. I try to find my B. Now, like before, I pick an X and I pick a corresponding Y. Now with this, I can now find my B to -1. Once I have my B, I can go back to substitute into this equation. Then I can get my rule for the mapping. But after you get the rule, you have to test with some values to check if it really works. So for example, I can put in 3. Now I evaluate 2 times 3 minus 1, that's 5, and that's true. I can try that for some other elements too. If it works, then my rule is right. Now let's look at another way. It's what we call the exponential map. So a map is exponential if you can write as y equals ar to the power x minus b. And we can find this if we have that two consecutive elements in the codomain are equal. So now with this relation, y equals ar power x minus b, now our x is an arbitrary element in the domain and our y is an image in the codomain. Now our A is the first element in the codomain. Now our B is the first element in the domain. Now R is the common ratio between two successive elements in the codomain. So with this, let's try an example. So in this one, I just try one of them and leave the rest for you to try. Now I try problem 2. Now for problem 2, we first check whether it satisfies the condition for an exponential map. Now we realize that after we find the ratio of two consecutive elements in the codomain, we get 3. So 3 over 1 is 3, 27 over 9 is 3, 81 over 27 is 3. Now we now have that our common ratio is 3. Now what's our A? Our A is the first element in the codomain. That's 1. Now B is the first element in the domain. That's 0. Now with this, we substitute it into the relation. Then we get y to be 3s to be the rule. Now to find P, what do I need to know? What do I need to do? I know that in the question we said that it was given that x is 5 and y is P. So I made a substitution into that. Then I have that y will be 243. That is P is 243. Now sometimes the maps are so complicated that you cannot find an explicit formula. So what you do is you do try and error. You try some rules and see which one works. And some people call this way method of inspection. So you just inspect and check there is no way of getting that inspection. There are some questions like that. Now, in some problems, you'll be given the map and be asked to find images. Or and when doing this, you just do some direct substitution. Let's try an example. So in this, we have several examples. Now let's look at the first one. You have the image of s is 2x squared minus 2. So if you find the image of 4, everywhere you see x, you put in 4, you substitute 4. And after doing that, we have the image of 4 to be 30. Similarly, in example 3, we are given the image to be 45. Now, for the image to be 45, we equate the whole rule to 45. Now we try finding our x, that gives us 45. And our x is minus 20. That means that if I put in back minus 20, I should be able to get the 45 here. That's the whole thing. With this kind of things, you can always go for it and come back to be sure that what you are doing is right. Now, let's look at what we call rational function, what makes a relation undefined. And we start by rational function. So rational relation is just a relation that is a ratio of two other relations. So a rational function is undefined if the denominator is equal to 0. Also, sometimes you will have a relation that's a root function. And it's also undefined when the value under the root is less than 0. Let's consider an example. So we have the image of s is 3s squared plus 2 all over 4s plus 8. To find the values that will make this relation defined, we equate the denominator to 0. And once we equate the denominator to 0, we have s equals minus 2. S equals minus 2. So s equals minus 2 will be the values of x that makes the relation defined. So on this note, we end here, and I encourage all of you to try more examples to increase understanding. You can always leave your comment below, and if you have some question, don't hesitate to reach me via email. And there's one important thing to always subscribe to my page and share to people, share to other colleagues of you who think this will interest them. So we meet again. Thank you.